In this video, I want to go through the game plan for model building. For some of you, this will be a very difficult topic, and others are going to pick it up right away. It's kind of weird how some do well and others don't. But what I want to try to reiterate to you and to remind you over and over again, I guess that means reiterate, is that there's one main idea going on here and lots of applications of it. We are going to be doing tests of hypothesis. Prior to watching this video, you should be familiar with the different model terms. Quadratics, interaction, qualitative variables, quantitative variables. We've talked about testing the model, so we've had some videos on that. And here's where we put it all together. And so let's start with an example. And the example I want to use is your project example. So we have one quantitative independent variable called x1, one qualitative independent variable that has two levels. So we have one dummy variable, x2. And so x2 is going to be 1 if one of your levels, 0 if not. And so let's say 1 if neighborhood A, 0 if neighborhood B. 1 if model vehicle A, 0 if model vehicle B. Whatever A and B happen to represent. You guys will define these for me when you do your multiple regression work for me. But that's how it's set up. And so we've talked about building the complete second order model. And so we get this guy here. We're going to refer to that as model 1. That's our starting point. That's our complete second order model, and that's where we begin. That's why building the complete second order model is so important. It allows us to see our starting point, our beginning point. We have linear, we have curvilinear, we have non-parallel interaction ideas, qualitative, quantitative, the whole, as my mother used to say, the whole kit and caboodle. Everything is in there. We have all the different possibilities. And so now we want to test that model. And so in a video format, here's how I'm going to do it. This is going to be kind of ugly probably, but boom, there it is. There's your model building for your project. And in general, this gives us a good idea of how we do the model building stuff. We start with, here's the way I want you to read it. Don't be overwhelmed. Some of you guys are running for the exits right now, I can tell. You start with your first model. We call that model 1. We just have that. We just check that. And the first test we do, think about that's the first test. Here's the second test, here's the third test, here's the fourth test. Upwards of 5 tests are necessary. And really, the number of tests or the order of the test is sort of irrelevant. I'm looking for the ideas of the test. We want to test. Our first test is always, does anything work? Is there anything that's useful in the model? Are any of the x's useful at predicting y? And so the way that I've done my notes here, I want to flash back and forth, but in order to do the notes, I just had to create a big chain. You should be able to flash back and forth between 2 pages, this game planning idea and then the models on the next page. And I'm going to be going back and forth between them. So we start with the global F test. You saw model 1 on the preceding page of notes. Beta naught plus beta 1 x1 plus beta 2 x1 squared plus beta 3 x2 plus beta 4 x1 x2 plus beta 5 x1 squared x2. We perform a global F test. And in order to do a multiple regression project or analysis, we're going to assume, for the purposes of our game planning, that we reject H naught. Our null hypothesis here was that all the betas, beta 1 through beta 5, are equal to 0, and we're going to be rejecting H naught. That's that global F test. That's not really a game plan or a model building. That's just the first test we do. I guess that's the first step of the model building. Over here, I have a branch that says fail to reject. On your projects, I'm not going to let you take this branch, but in general, you could. This would be the stop. There's insufficient evidence to indicate anything is useful in the model. Stop right there. You're done. Okay, obviously I don't want you to do that on the project, so you can't go there. Everybody's going to be rejecting. Everybody's going to say there's something useful in model 1. And now the game plan becomes necessary. Find it. What is it that's necessary? What is it that works? And so the next step on our model building tour is to do the quadratics test. And so what we're going to do, and we want to think of these models now, or these tests, as comparing 2 models. The quadratics test, we're going to compare model 1 to model 2. When we do that, we're going to have 2 possible conclusions: reject or fail to reject. But before we get too far here, we got to ask the question, what's model 2? If I want to test the quadratic terms in model 1, what's model 2? Now, if you watched my testing the model videos, this is the example I went through. I said, here's model 1, let's do the quadratics test, but let's go to the next slide and take a look. There's model 1, and we're saying in model 1, we want to test the quadratic part of model 1. We want to test to see if the x1 squared, the x1 squared, x2 term are useful. That's why we specify that beta 2 and beta 5 are equal to 0. That's what the null hypothesis for the quadratics test would be. Again, we had a little discussion of this when we talked about the partial F test or the best subset test in the testing models video, but that's the test we want to conduct. So if this is considered the full model, let me put an F here for the time being, what would be the reduced model that we would compare it to? Well, if we're testing the quadratics, we say the full model is the model that has the quadratics in it, and then we compare it to the model that drops them out. And so if we take those terms out, if we take the quadratic term here out, and we take the quadratic term here out of the full model, look what we're left with. Beta naught, beta 1x1, beta 3x2, beta 4x1, x2. That's exactly what we have in our reduced model. We're testing two terms. We call that a partial F, or as statistics calls it, a best subset test. And that's the test. That's the test statistic and p-value that we would generate to see which of these two models we like. And so based on that test, and that, or let's say based on that test statistic and p-value, that's going to help us to decide which of these two branches to come down. When we compare model 1 versus model 2, if we reject H0, we show those terms are useful, we stick with model 1. You'll notice whenever we reject H0, we stick with the big model. If we fail to reject, if we say there's insufficient evidence to indicate those terms are useful, then we take them out and we go with model 2. And so when we do the global test, we're either going to stick with that model, model 1, or we're going to stop. Every other test, we're either going to stick with the full model, either keep the full model, or go with the reduced model. And so after the quadratics test, you're going to tell me which of these two models you like. If you rejected the quadratics test, you said model 1. If you didn't like the quadratics, if you said they're not necessary, you're going to like model 2. And now we test the interaction. That next test, we go global, we go quadratics. This is the result of the quadratics. You're not going to be with both these things. You're either going to be in model 1 or in model 2. Now what am I doing here? I'm getting this set up, because if you're in model 1, what are you going to compare model 1 to test the interaction part? Because that's the next level of testing. If you said we need the quadratic, how do you test the interactions in model 1? Well, I'm going to propose model 3. Model 3 takes a look at the full model, and if you told me the quadratics are necessary, model 1 would be considered your full model, and then you're going to compare it to the reduced model. The reduced model is always found by taking out the terms you want to test. Look how many terms I got boxed in right there. What kind of test would that be? I'm testing two terms. That's not a global. That's not testing everything. It's not a t-test. T-test test 1. That's, again, a best subset test. And so if you told me the quadratics are necessary, that's how you would test the interaction term, or terms, of model 1. But there's the other branch. If we rejected the quadratics test and we kept the quadratics, that's exactly what we do. We would now test model 1 versus model 3. But what if you're on the other side of that decision? What if you were on the fail to reject side? What if you said, when you compared 1 versus 2, fail to reject, there's insufficient evidence to indicate the quadratic terms are necessary? Well, in that case, and let me get to a different color ink here, this would be your full model. Model 2 would be considered your full model, and you would compare it to model 4. So again, I asked the question, what would model 4 be? How do you test the interaction component of model 2? Well, you might notice here there's only one interaction component, or one interaction term in model 2. So to compare 2 versus 4, we drop it out. And so this would be, model 4 would be considered the reduced model when you go to do the interaction test of 2 versus 4. You're only going to do one of these tests, right? That's the part that people mess up. Occasionally I'll get students that come in and they hand me a whole stack of printouts and say, here are all my tests. And I'll say, there are. And there's like 10 different printouts. I was like, what are all these? And they're like, they're the tests you want. I said, I don't want all those. I'm like, sure you do. And they'll go to the game plan. They'll say you want to test here, you want to test here, 2, 3, 4, 5, 6. They give me 7 printouts. And I said, I don't want 7 printouts because you're not going to do both of these guys. You're not going to do both these tests that I'm highlighting right now, that I'm arrowing. You're not going to do 1 versus 3 and 2 versus 4. You're going to do 1 versus 3 or 2 versus 4. How do you know which one? Show me your quadratic test. Because that's going to indicate to me which of these 2 branches you're going down. If P is low when you do the quadratic test, you should come down this branch. If P is high, well, then you're coming down this test. What do you mean high and low? We compare it to our alpha. What alpha are you testing at? And so that's how you do the interaction test. It's either 1 versus 3 or 2 versus 4. You take a look at what you're considering your full model. We figured that out right here. Which is your full model, 1 or 2? And then you do an interaction test. And now we repeat the process. And so if you're over here in the 1 versus 3 side of the decision tree, when we go and test the interaction, that's the best subset because there's 2 terms we're testing there. Don't believe me? Go look at your models again. Look at 1 versus 3. There are 2 different terms we're testing. Well, if you reject, we look at the new p-value from the new printout. If we reject, we're going to go with model 1. Now you see model 1 has a red circle around it. I'll talk about that in a second. If we fail to reject, we go to model 3. Over here, if we're doing 2 versus 4 and we reject, in general, if you are testing 2 models, when you reject, you like those terms, don't you? Because the test says these terms don't work. If you reject it, you're saying, oh, I like those terms. I'm going to keep them in. I'm going to keep the full model. And when you fail to reject, you don't like those terms. You're saying they don't help, and so you're going to go with the reduced model. And so depending on which decision we make, reject or fail to reject, that tells us to go with the full or the reduced model. And you see a couple of these guys have red circles, a couple of them have new boxes. Let's go and talk about that. So let's go flip over to the next one. Now remember, we're going to test interaction. Depending what decision, I'm sorry, that's not true. We just tested interaction. 1 versus 3, 2 versus 4. We just tested interaction. And now our goal is to test the qualitative variable. So that's what we're going to next. But let's take a look at our 4 models and talk about it a little bit. Okay, we've come out of the global test. We rejected the quadratic test. We either rejected or failed to reject. The interaction test, we either failed to reject or failed to reject. So we end up with one of these 4 models. Now we want to test the qualitative part. Let's just do a what if here. If we were to say model 1, so we rejected the quadratics, we kept them. We rejected when we tested the interaction, we kept them. We said model 1's best. Identify the qualitative piece of model 1. And anytime you're using an x2 term, that would be the qualitative piece. You'd be saying right there is the qualitative piece, right? And so the qualitative test would say beta 3, beta 4, and beta 5 are all equal to 0. In other words, these 3 terms don't work. But we just said at least one of these terms works. Because we just did the interaction test. That was the last test we looked at, and we said at least one of those terms work. And now we're saying, hey, let's see if any of these 3 terms work. What I'm trying to point out to you is this is an unnecessary test. If we tested model 1, if we tested the qualitative portion of model 1, because we already know these guys here work, we know we're going to reject. So if we reject and keep the quadratics, and we reject and we keep the interaction terms, we're going to reject for the qualitative. If we reject for the quantitative, we're done. Model 1 says you're done. Model 1's your best model at that point. Okay? Likewise, if we said model 2, okay? If we said model 2, what happened was we tested the quadratics to get to model 2, kind of go back to that decision tree. To get to model 2, you said we didn't like the quadratics, so we got rid of them, but we do like the interaction. We know this term here is useful. How do I know that? Because I just tested the interaction terms, and that's what we said. We said reject. That's how we got to model 2. Okay, now, test the qualitative portion of model 2. What would you do? Well, you would test these 2 terms. We already know this one over here is useful. And so again, this is an unnecessary test. That's why you see in your game plan that the 1 and the 2 are circled. Once interaction's present, you don't have to test x2 by itself. You don't have to test x1. We're done. And so you're done your model building there. If you keep interaction in your model building is pretty straightforward. It's done. A couple tests and you're done. But look at the other situation. Take a look at model 3. And again, think about, go back to the game plan. Look at the game plan, that decision tree. How did you get to model 3? You tested the quadratics, and we kept them, right? We said model 1 was the best model. Then we did 1 versus 3 and tested the interaction, and we dropped the interaction out. And so we're left with model 3. We're saying here's our better model at this point. Have we ever said x2 is necessary? I don't think so. Not yet. And that's what we want to test now. And so we want to compare model 3 to model 5. What's model 5? Well, what terms do we want to test? We want to test the qualitative term. So you're sitting there with a paper right now, hopefully. Put your thumb over to beta 3x2. What you're doing there is you're saying, here's the full model. We're considering model 3 to be our full model now. Put your thumb over the part you don't want. Put your thumb over this part. What are you left with? That's what we call the reduced model, model 5. Likewise, if you said model 4 is your best model, and again, how did we get to model 4? We tested the quadratics. We got rid of them. That was a fail to reject. We tested the interaction. We got rid of them. A fail to reject. Now we want to test, and again, I'll change color of the ink here. We want to compare 4 to 6. What's 6? We want to test the qualitative term of model 4. How many terms are we testing in this qualitative? Just a single one. That's a t-test. That's a t-test. It's a different part of the print. Actually, it's a different printout than the best subset or the partial F test, but it's a different location on the printout than the global F. Again, go back and review the testing the models printouts, or not testing the models video. And I'll go through and I'll talk about how we do each of these tests in statistics. And so that's the next level of testing. And what we're talking about right now is 3 versus 5 and 4 versus 6. Look at your p-value. Determine which is the best model. If p is low, reject the null. Okay, so if p is low, you stick with the full model. We would do that here and we would do that there. If p is high, you go with the reduced model. And again, you're seeing some circled numbers here. The circles mean we stop. Now again, I'll go and take a look at why we stop. We have one more test if needed. Sometimes we need them, sometimes we don't. Let's go to the models and take a look. We've already stopped here. We've already stopped here. Now we're going to go and take a look at the next level of testing. We stopped here. Actually, we didn't stop here. We stopped at 1 and 2. Now, if we kept the qualitative term, and I say go ahead and test the quantitative, we've already said the quantitative is useful, so we would stop. Here, we've already said the quantitative is useful. We'd stop. Here, the quantitative is the only thing that's left. We stop. In order to get to model 6, we said something works. It wasn't the quads. It wasn't the interaction. It wasn't the qualitative. There's only one piece left. We're going to stop. That's going to be your best model. The only model where we have still more testing to do is model 4. Why? Well, to get to model 4, look at the path. Go back to the game plan. You do the global F test, said something worked. You test the quadratics. To get to model 4, we failed to reject. We got rid of it. Test the interaction. We failed to reject. We get rid of it. Test the qualitative, and all of a sudden, yeah, this term here works. But what about this guy? Does that one work? We don't know, and that's what leads us to our last possibility. And that's the model where we have the qualitative variable, but not the quantitative. And so we end up comparing 4 versus 7. If we reject, we go with the model that has both x1 and x2. If we fail to reject, we drop out the x1, and we end up with a model that just has x2. And so here's your pathway. When you tell me model 2 is your best model, I want to see the printouts that get you to whatever you say your best model is. If you say it's model 5, then you're going to show me these printouts. And I should look at these printouts and see the p-values that end up at model 5. So I just want to see your path. Sometimes you need the global, the quadratics, and the interaction, and you're done. Model 1 and model 2 will get you there. Sometimes you have the qualitative tests, 3, 5, and 6 get you there. Sometimes you have to do the quantitative test as well, 4 and 7. Depends on your data. The question I get all the time is, which model do I want? I want the one that fits your data the best. Depends on your data. Do you need curves? Then you're going to be rejecting here. Do you need lines? You're going to be failing to reject. Are they parallel? In which case you're going to be failing to reject. Are they non-parallel? Well, you're rejecting. Do you need different lines or curves for your 2 different locations or automobiles? Well, that's the reject H-naught here. Or will a single work? And so we're trying to answer all these questions. The complete second order model put in all these ideas. Now we're verifying that they're actually needed. And so that's how we do the game plan. Now the last thing, and I think I have this slide 2 more times, I wasn't sure how many more times I would need it. Here are the models again, and I don't know why I have them in as an animation, but we'll go there. What do they look like? That's what I want you to think about. What's the picture? What do they look like? That's what I want you to think about. What's the picture of model 1 look like? This sometimes helps you guys figure out what it is these different components do. So when I say draw the y-x1 relationship, you see that term right there? What does that bring? What does that do? Doesn't the square term add curves? So we're going to have curves. I won't even say different yet. We're going to have curves. The relationship between y and x1 is going to be curvilinear. There's going to be two of them. There's going to be two different relationships. How do I know that? Because we have a qualitative variable that's got two levels. What's the interaction do? It makes them non-parallel. So maybe this is the x2 equals 0 equation. And maybe this is the x2 equal to 1 equation. Now when I ask you to draw these lines or curves, when I ask you to draw the graph, I don't care what you draw, because sometimes I get students, how did you do it? Why did you draw an upward curve? How did you know the non-parallel that would look like that? Couldn't they have been non-parallel? I don't care. I don't care what you draw. I just want to see two non-parallel curves, because that's what this model allows for. How about model 2? What's it allow for? Still 2. They're still non-parallel, but what changed? When you compared 1 and 2, when we were testing the quadratics, model 1 kept the quadratics, model 2 dropped them out, right? Model 2 says we still need non-parallel, but now they're lines. And so maybe model 2 looks like this. There's x2 equals 0. Here's x2 equal to 1. We have two non-parallel lines now, not curves. What about model 3? When you look at model 3, what do you see? I still see curves. I still see two of them, but what's dropped out of model 3 now? Now when you look at this picture, maybe there's x2 equals 0. There's x2 equal 1. They're parallel curves. Model 4, hopefully you're seeing what's going on now. I have two of them. If I could draw this correctly. Oof, that's a little rough. But those are two parallel lines. That's what you should be drawing here. Two parallel linear, because x1 has only got a linear. There's no squared term. Parallel, there's two of them, and parallel because there's no interaction. There's no interaction here or here in models 3 and 4. That's the piece that drops out. Model 5. Look, I got a curve, right? And what happened to x2? Well, in model 5, we said x2 is not necessary. We failed to reject when we tested to see whether we needed the qualitative variable. So model 5 says this one curve is going to work for both x2 equals 0 and 1. We don't need to differentiate between our two models of vehicle or our two locations. The same curve works for both. Model 6, it's a straight line. Now, whether it's upward or downward sloping, that depends on the value of beta 1. And then there should be one more. This is probably the hardest graph of all of them because it sure looks like a line. But remember when we talked about qualitative variables, x2 can either be 0 or 1. You're going to get a value here. We're going to estimate the sales price of all Camaros is right there. The sales price of all Mustangs is there. You're going to get 2 points. Model 7 is the weirdest model that we're going to run into. It's the one that students struggle with the most. But that's what it'll look like. It'll be 2 points. And again, maybe the left-hand point is 0 points lower, the right-hand point's higher. But that's the picture that you're going to end up with. So that's the game plan. Lots of information there. Some of you guys are all over it, thinking, yes, I got it. Others are looking at this thinking, holy cow, what just happened? 24 minutes of awesomeness just happened. Okay, you're probably not thinking that. But what I'm going to tell you is don't run away from this stuff. There's a couple things you can do. First thing you can do, obviously it's in video format. You can go back and watch it again. But here's what I recommend. I would recommend either getting your project data and going and playing around with it, or asking some questions. Discussion boards, come up and talk to me. Emails, discussion boards, getting a hold of me. You know how to get a hold of me. You know how to get a hold of the TA. Ask the questions. Don't stay away from it. And after you play around with it a little bit or ask some questions, go back to your projects. I find that if you don't see it right away, and I know there's a segment of the class right now that doesn't, and that's okay. If you don't see it right away, you got to practice. You got to get in there, start looking at printouts, start understanding. If you do understand it right away, here's what I'm going to suggest to you. Think about the model building. Think about model 1. What happens as I change my variables? In our building the complete second order model video, I talked about another model where you had 3 levels for the qualitative variable, and we actually built a complete second order model. Think about what the game plan looks like then. Think about how the models will change. It all is based on model 1. So if you start with a different model 1, how would you test the quadratics? How would you test the interaction? How about the qualitative? There's corresponding changes that would be made. And once you see that, you're good to go. Because now I can start you anywhere. If I say test the quadratics, you're looking for squared terms. If I say test the interactions, you're looking for where we multiply 2 variables together, x1s, x2s. Maybe there's an x3 in that one. Identifying the qualitative is taking a look at how we define our variables and our x's. Identifying the quantitative, same thing. And so once you get how we're going about it, what you see in the game plan is all those boxes are basically the same. The boxes are comparing 2 models. The difference between them is what you're starting with, what you're considering the full model there, and what you're testing to get to the reduced model. So take a look. If you have questions, you can post them. You can ask them, and then get to work on your projects and your multiple regression projects and play around with your data and see what you get. Good luck.